This is SpaceTime Series 24, Episode 9. Coming up on SpaceTime, a new origin for sunquakes. It now seems the interstellar asteroid Oumuamua is not a frozen hydrogen iceberg, and ESA's Kiruna ground station in northern Sweden celebrates 30 years of operations. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has determined that sunquakes actually originate from beneath the surface of the Sun, and not from above as previously thought. But the findings, reported in the astrophysical journal Letters, still can't explain exactly what causes these ripples on the surface of the Sun in the minutes following a solar flare. Sunquakes are acoustic energy waves travelling across the photosphere, that's the Sun's visible surface, from the same active region which hosted the solar flare. Scientists originally suspected that they were generated by magnetic forces or heating of the outer solar atmosphere where the flare erupted. However, new observations by the helioseismic and magnetic imager aboard NASA's Solar Dynamics Orbiter spacecraft has allowed astronomers to study sunquakes using a new technique. They observed a series of unusually sharp sunquake ripples generated by an M9.3 class solar flare, and they used a technique called helioseismic holography to trace the waves back to their source. And here's where it got interesting. Instead of travelling down to the photosphere from above as expected, scientists instead saw sunquake surface ripples emerging from deep beneath the solar surface following the eruption. They were able to determine that the acoustic source triggered by the solar flare was around 1,127 kilometres below the surface. While it hasn't answered key questions, the findings do help explain why some sunquake characteristics look so remarkably different compared to the solar flare which triggered them. This is SpaceTime. Still to come. It now seems the interstellar asteroid Oumuamua is not a frozen hydrogen iceberg, and ESA's Kiruna ground station in northern Sweden celebrates 30 years of operations. All that and more still to come on SpaceTime. The idea that the interstellar asteroid Oumuamua could be a giant frozen hydrogen iceberg has been dashed following new research. Oumuamua was the first asteroid to visit our solar system identified as having an interstellar origin. The rocky cigar-shaped object was first detected on October 19, 2017. It was spotted by the University of Hawaii's Pan-STARRS 1 telescope just after it had swung round the Sun and was on its way back out of the solar system. The 400-metre-wide asteroid raised more interest when observations showed that it had suddenly begun to accelerate as it sped away from the Sun and off into interstellar space. That's something which shouldn't happen. And that raised speculation that Oumuamua may have been formed deep inside a molecular gas cloud and was made out of molecular hydrogen ice. As the hydrogen ice melted, it was acting like thrust, accelerating Oumuamua at ever higher velocities. The idea of Oumuamua being a giant hydrogen iceberg could also explain its unusual elongated shape. But a new study by scientists including Abraham Loeb from Harvard University shows that Oumuamua-sized hydrogen icebergs would be destroyed within their first 10 million years of existence by starlight heating. Loeb and colleagues also found that collisional heating would also rapidly wear away such an object at its birthplace, potentially destroying it well before it could even escape into interstellar space and begin its long journey to our solar system. The authors say even the formation of such a hydrogen iceberg seems unlikely. That's because it would be difficult to form the icy grains rich in molecular hydrogen in the dense clouds that could give birth to such an interstellar asteroid. The findings also raise implications for one of the proposed candidates for dark matter, that mysterious invisible substance which makes up more than 70% of all the matter in the universe, but which appears to interact only gravitationally with normal matter. Scientists have no idea what dark matter is, even though they admit there's lots of it around. One hypothesized component were objects called primordial snowballs, theorized bodies made out of molecular hydrogen ice in the early universe. But the new research by Loeb and colleagues shows that such snowballs are unlikely to have been able to form, and even if they did, they certainly wouldn't have survived to the present day. This is SpaceTime. Still to come, ESA's Kiruna ground station in northern Sweden celebrates 30 years of operations. And later in the science report, new researchers confirm that the COVID-19 virus likely lingered longer in its Wuhan birthplace than what the Chinese government were willing to report. All that and more still to come on SpaceTime. The European Space Agency's Kiruna ground station in northern Sweden is celebrating 30 years of operations. Located near the top of the world, 68 degrees north, the Kiruna ground station is ideally positioned to support polar orbiting missions. The station's a crucial gateway for much of the data enabling scientists to study the Earth's oceans, water and atmosphere, forecast weather, and understand the rapid advance of climate change. Its two sophisticated antennas also support many of ESA's scientific missions, including Integral and Cluster. The station's part of the European Space Agency's S-Track network, linking all agency missions to the European Space Operations Mission Control Center in Darmstadt, Germany. This report from ESA TV.
Across the globe, a network of eyes and ears look to the sky. They tilt and sweep, catching signals from space explorers across the solar system or in orbit around Earth. These ground stations gather data collected in space and also act as mission control's voice, transmitting commands and controls, the means of communication between spacecraft and the engineers who sent them on their journey. This is ESA's S-Track network. The S-Track network is a global system of ground stations linking European spacecraft to the agency's Mission Control Center in Darmstadt, Germany. Whether they are circling Earth, watching the Sun, observing distant stars, or voyaging to other planets, asteroids or comets, these technically advanced ground stations and antennae can link up with any ESA spacecraft.
When you think about space, we never think about the very important ground network, because you couldn't communicate with the satellites if you wouldn't have the ground network, and this is absolutely essential.
The core network comprises 7 stations on 3 continents, with 3 large 35-metre deep space antennae in Australia, Spain and Argentina. 4 stations with smaller antennae are used for communication with nearby Earth-orbiting missions. They are located in Belgium, Portugal, French Guiana and Kiruna, Sweden.
Kiruna is a strategic asset for within the S-Track core network, playing a fundamental role for the support of all ESA missions with our own infrastructure.
Kiruna, within our S-Track station network, stands out, first of all, for its privileged latitude, high in the north, so it can capture most of our polar orbiting satellites, typically Earth observation satellites, but it can also serve some of our science missions, like our Gamma Ray Observatory Integral.
In 1986, ESA and Sweden agreed to establish satellite tracking facilities near the top of the world, in the region of Salmijavi. Eventually, the station was constructed on a 20-hectare site, some 38 kilometers east of Kiruna town.
Kiruna is the northernmost ground station of the S-Track family. It sits beyond the Arctic Circle at about 68 degrees of latitude, and this is an optimal geographical location for the support of polar orbiting satellites, providing increased communication opportunities for this kind of mission.
In the agreement, Sweden designated the Swedish Space Corporation to carry out on-site operations, and today SSC experts continue to run the station.
I started in 1988 as a technician. On my first working day, we started bringing in the ERS-1 processing equipment into an empty building.
King Carl Gustaf XVI of Sweden inaugurated the Kiruna site. It consisted of a newly constructed building, a primary and emergency power plant, roads, data cables, a calibration site, and a single 15-metre dish antenna, Kiruna 1.
The relevance of the station is remarked by the inauguration 30 years ago, when the King of Sweden himself, together with the former Director General of ESA, Dr. Rainer Lust, pushed the button that triggered the first track of the antenna as a symbolic act of the beginning of the operational life of the station.
I got the task of trying to solve the problem that this button should activate the antenna movement. So at the time we had a laptop with a computer program which I could pre-program the movement of the antenna, but how should I connect this button to it? In the end, it was a very simple solution. I sat myself inside the antenna in front of the computer. When the king pressed the button, the sirens went off, and I just pressed the enter button of the computer.
In July 1991, the station began routine support to ESA's new ERS-1 mission. A few years later, in 1994, the station's systems got their first upgrade, meaning the station could support the follow-on ERS-2 mission. This enabled tandem operations with ERS-1, a first for European spaceflight.
In 2002, Envisat was launched and Kiruna was providing support as prime station for telemetry tracking and command, as well as for X-band reception and processing.
When Kiruna took on communication responsibility for this then new ESA satellite, it was the largest civilian Earth observation satellite ever flown, and it was clear that this 8-ton satellite and its 10 onboard instruments would generate large quantities of data. A station upgrade was required, and a second 13-meter dish antenna was installed for high data rate capability, using high-frequency X-band radio signals. Over the course of 30 years, the Kiruna station has established an enviable record, providing reliable communication links with dozens of Europe's most important missions, such as ERS-1 and 2, Envisat, and Gochi.
Kiruna is basically the backbone ground station for the Earth observation missions. We all know it, we all use it, it works, and it's ours.
Today, Kiruna provides tracking services to the Copernicus constellation, composed of Sentinel-5P and the Sentinel-1, 2 and 3 satellite pairs. ESA's Earth Explorer missions, such as Aeolus, Swarm and Cryosat-2, are also part of Kiruna's daily tracking schedule.
Almost all Earth observation missions have polar orbits and pass some 10 to 15 times over the pole. And a station close to the pole can contact with satellites 10 to 15 times a day.
In a typical month, more than 750 hours of communication link-ups are made between Kiruna and passing satellites, up to 15 different spacecraft in all. This means the station is providing an average tracking support for over 25 hours each day with its 2 antennae. These communication passes enable the station to download vital science data and upload fresh commands for the coming orbits. For most Earth observation satellites, this is usually done in a very tight time window of just 12 minutes, while the satellite is in direct line-of-sight view.
Kiruna is also an example of a station which is multi-mission, which provides different kind of supports and can be reconfigured very quickly due to also the nature of the passes, which are normally not for polar orbiting missions, are never more than 10-15 minutes. It's a different story if we talk about integral. As a science mission describing a highly elliptical orbit, the passes of integral are often exceeding 50 hours coverage from Kiruna, so the antenna moves very, very slowly.
Kiruna's antennae and station systems are operated remotely from the Network Operations Center, located at ESA's ESOC Control Center in Darmstadt, Germany. Here, operators are on duty 24 hours a day, year-round. This efficient workflow allows the station's electronic and data systems to be quickly reconfigured between communication passes with different satellites.
Generally what we do is we prepare the commands in advance that we're going to uplink in a certain pass, so typically a Kiruna pass. These commands will execute offline out of coverage mostly, and after the following passes we will check that those commands are successfully on board and that the satellite is behaving as it should be.
For maintenance and day-to-day troubleshooting on site, Kiruna relies on a local team of engineers. These specialists also work on console, if direct intervention is needed during critical spacecraft maneuvers or launch activities.
Kiruna has a backup control center. This is a mini system which allows ESOC to command the Sentinels 1, 2, 3 and 5P in case of an emergency here in ESOC.
Another important feature of the Kiruna station is its ability to provide vital real-time contact with new satellites during their launch and early orbit phase, or LEOP. In this period, it's crucial to quickly and accurately catch a spacecraft's first signals only minutes after launch, allowing operators on the ground to take control of the mission and switch vital control systems on. This critical capability means that when mission controllers need reliable communication in risky situations, they often rely on Kiruna. In the past decade, the station and its maintenance and operations team have typically supported one launch every year.
Kiruna also guarantees us the technical excellence visa behind the ground station. So for this very specific phase where we could encounter all sorts of contingencies, where we don't know where the contingency actually is, whether it's a spacecraft issue, an orbital issue, a radio frequency issue, we know we have the experts here on site who know the station inside out and are ready to collaborate with us and to find a way out.
As space technology develops and space becomes increasingly important to daily life, the Kiruna station will continue reinventing itself. It will have to support new missions and accommodate future technologies. New missions are already downloading several terabytes per day, or even per pass, via Kiruna, and in future this will only increase as the amount of data gathered by satellites and the knowledge this provides grows exponentially.
During the 30 years of operational life of Kiruna, the station has continuously undergone a gradual development and expansion, mainly driven by the challenging operational requirements from the multiple missions supported. And this trend will continue in the future. Emerging technological trends are coming together with the new series of Earth observation and scientific missions.
The main driver of station evolutions is, of course, the needs of the various missions and the direction where these missions are converging. Mainly now we talk about S-band and X-band as Kiruna supports, but it's already reality higher frequency bands like K-band at 26 GHz, where the bandwidth, the available bandwidth is much larger and the amount of data that can be dumped to the station from the satellite is considerably larger.
In the next decade, the evolution of the Copernicus program will add more satellites to be supported from Kiruna. That will require more tracking hours and new capabilities.
ESA aims at further evolving the station to keep on playing a fundamental role in the support of this mission during critical and routine phases, as well as to serve as a reference facility for the validation and troubleshooting of new technological developments. So 30 years has served to consolidate Kiruna as an extract reference station for the support of near-Earth communications, and solid foundations are laid to continue its expansion and development to the support of the mission to come.
For Kiruna, this will be a challenge, but also an opportunity to once more demonstrate its importance as a vital link between Earth and space. We can no longer conceive of a society without space technology. While we might often think of the importance of satellites orbiting our planet, or spacecraft voyaging to distant destinations, we should not forget how crucial ground stations like Kiruna are, how they make space possible, and how they help humanity move into the future.
And in that report from ESA TV, we heard from ESA's Director of Operations with the European Space Operations Centre, Ralph Denzig, ESA's Kiruna Ground Station Manager, Guillermo Lorenzo, Kiruna Maintenance and Operations Manager, Kenneth Kakrula, Spacecraft Operations Manager Isabel Rojo, Ground Station Systems Engineers Salvador Marti and Luca Minani, and Sentinel-2 Spacecraft Operations Manager Michelle Baker. This is SpaceTime. And And time now to take another brief look at some of the other stories making news in science this week with a science report. New researchers confirmed that the COVID-19 virus likely lingered longer in its Wuhan birthplace than what had been reported by the Chinese government. A report in the journal PLOS Neglected Tropical Diseases claims the findings are based on testing of more than 60,000 healthy people in China for SARS-CoV-2 antibodies. Researchers tested for two kinds of antibodies, IgG, which suggests a previous infection, and IgM, which indicates a current or recent infection. According to the IgM positive rate of 0.46% in Wuhan, the researchers estimate that thousands of people must have been infected asymptomatically between March and May in 2020. That's after the infection was already thought to be under control in China. The deadly virus, which is now suspected of escaping from the Chinese government-run Wuhan Virology Laboratory a year ago, has killed more than 2 million people worldwide and infected more than 100 million others. A report in the journal Nature Climate Change warns that cities across the globe could warm by more than 4 degrees Celsius under a high-emissions climate change scenario. Cities tend to warm more than other areas because their built surfaces are made out of concrete and asphalt, which absorb more heat and inhibit cooling. And with more than half the world's population now living in cities, the impacts are likely to be felt by most of us. Scientists have identified a spectacular new genus and species of flower from the mid-Cretaceous. Sunburst-like reached the heavens was frozen in time by Burmese amber. The flower, reported in the Journal of the Botanical Research Institute of Texas, is tiny, just 2 millimeters across, but it has some 50 stamens arranged like a spiral, with anthers pointing towards the sky. A stamen consists of an anther, that's the pollen-producing head, and a filament, that's the stalk that connects the anther to the flower. The specimen's thought to have been part of a cluster on a plant that contained many similar flowers. The new discovery is an egg-shaped hollow floral cup, that's the part of the flower from which the stamens emanate, and an outer layer consisting of 6 petal-like structures. The flower became encased in amber on the ancient supercontinent of Gondwana and rafted on the continental plate across the oceans from Australia to Southeast Asia. Geologists have been debating when this chunk of land, known as the West Burma Block, broke away from Gondwana. Some believe it was around 200 million years ago. Others claim it was more like 500 million years ago. Scientists have published a full genetic code for the egg-laying monotreme mammals platypus and echidna. Monotremes display a unique mix of mammalian and reptilian features and form the most distantly related and least understood group of living mammals. Their genetic blueprint provides fundamental insights into their unique biology and into the evolution of all mammals. You can read the details in full in the journal Nature. They're delicate, awkward, they sound crackly, and they wear out. But vinyl records are making a comeback, again. It seems to be a story which does the rounds every few years. While reel-to-reel players, cassettes, 8-track cartridge players, VHS, beta and laserdiscs have all died, vinyl keeps returning from the grave. With the details of why this keeps happening, we're joined by Alex Sahara-Voigt from ITY.com.
Yeah, look, I think it's more of a nostalgia thing. I mean, you know, the vinyl records had that beautiful big album art that was sort of in between the size of an A4 sheet of paper and an A3, or a letter and something that's twice the size of a letter sheet of paper. I'm not sure what the US equivalent is, but it was big. And, you know, there were famous album covers that just
Think
didn't
of a family-sized pizza, folks.
That's right, yeah. And it didn't translate as well onto a smaller CD. And, I mean, nowadays, when you download something from iTunes or, you know, your Apple Music or equivalent services, you can get sort of album covers which show on your phone, and there can be little digital booklets. But that big, beautiful album art, it's something that you can go into. In Australia, you've got JB. I'm guessing in the US, places like Best Buy and Walmart, you probably have a vinyl section there. We certainly do in Australia. And all the big new albums are there, all the classic albums are there from all the Rolling Stones and the Beatles and Elvis and all these different artists. So people love that feeling of putting the disc on the record player and dropping down the needle
on the record.
That's right, and you know, the DJs like to scratch.
I'm old enough to remember playing vinyl records on the radio when I was a DJ, and I was actually there when the changeover. Well, I sound old, don't I? I was actually around when the changeover occurred from vinyl to CDs, and then onto, of course, as we do it now with Basically, they're MP3s or MP4s, depending on where you're working nowadays. I was there for all of those changes, and I'm shocked to find that vinyl is making a comeback. It's been doing that for a while now, but it's been at least a decade of making a comeback. Looks like vinyl's here to stay.
The thing is that, you would have thought that it would have died a long time ago. I mean,
anyone who says the music quality is better is fooling themselves. It's not.
Well, you have the crackles, you have the pops. I mean, every time you're playing the audio, the needle is scratching the vinyl and sort of damaging it with every single play. Yeah, with every single play. But it's just got to be the nostalgia element to it.
Yeah, but a lot of the people who are buying it aren't old enough to have that nostalgia effect. They're YZ and millennials. They don't know about things like nostalgia from vinyl records.
Well, they probably have watched movies or heard about it from their parents or grandparents. But it's also something that's, different. I mean, nowadays you can grab your phone or a tablet or a computer and it's a jukebox of 70 or 80 million songs. I mean, it's funny to watch those YouTube videos where they hand young kids today a Walkman, for example, and they say, take a look at this. And the kids are amazed. And they see the cassette and it's like, it only goes in one direction and it only has 60 minutes of music and you've got to turn it around. And this sort of blows their minds that they can't believe. I mean, I remember when I first got a video recorder, I was recording, we got home and we turned it on. I started recording the Saturday morning cartoons. And I just imagined that I could edit out the commercials, advertisements afterwards, right? Yep. I just had this expectation that you could. Now, a child today, if they have that expectation, it's correct. But back then, unless I was going to cut tape and try and splice it together, which you didn't do with videotapes.
No, what you do what I did as a kid. That is buy two video recorders. And
that's right. Well, you could
edit it from one to the other. That's what I used to do.
That's right. But you would lose quality that way. Of course, digitally, you don't lose any quality at all, in theory, anyway, unless you compress it. So look, it's just one of those things where audio cassettes have died, more or less. You see them at second-hand markets and trash and treasures, but that's about it. You don't see them on sale in the gas stations anymore.
Survived for a long time? A version of the 8-track that used to be in cars back in the 60s and 70s. That survived in radio as a way to play ads for years and years. In fact, in the 80s and early 90s, we were still using audio carts to play inserts and things like that.
I remember when people were still using that. I mean, it's a little bit like with Beta versus VHS. Beta remained as a professional standard.
Oh, yeah, Beta Max was the professional standard because Beta was better quality than VHS. Right. And Beta Recorder was the home version thereof.
That's right. And so things had a niche. Vinyl seems to have been one of the few things to have broken out of niche status, and you can buy it again. And people buy these incredible amplifiers and speaker systems and pretend to themselves that they definitely can hear better audio quality. But then, of course, these days you have these lossless file systems that capture all of the frequencies and can play it back, especially on incredible headsets with unbelievable detail. So, look, it's one of those things. How long it's going to last, I don't know. It'll probably be the format that'll last the longest.
That's Alex Harov-Reut from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.